During second semester, you're going to be using something called a diamond problem, and then also something that we're going to refer to as a rectangle, almost every day. And so it's really important to get good at these before we even start learning the concepts that you're going to learn that go with them. If you're good at these before we start those chapters, it's going to help you a lot to understand everything that we're doing. So we're just going to practice kind of setting up diamond problems and rectangles with the packet that you're going to work on over break. And that way, once we get to them in the chapters in second semester, you'll already have an idea of how to do it. It won't be learning two things at once. So the first thing we're going to look at is a diamond problem. And basically what you're doing, the reason that they call it a diamond problem is if you looked kind of, I'm going to draw it in with my highlighter, like that, you would have that diamond shape. But we take a shortcut, we don't draw the diamond shape around it, we just draw a big X every time. And what you're looking at is two numbers, and I'm just calling them A and B here. When you multiply these two numbers, you get the product of those two numbers, and it always goes in the top of the diamond. When you add those two numbers, it always goes in the bottom of the diamond. So it's basically just going through numbers and figuring out what two numbers multiply to be this and add to be this. Hardest part about this is once we start including negatives, and also you just have to remember product at the top, sum at the bottom. That's something you're just going to have to memorize. Here are a few hints about helping you with the diamond problem and figuring out your signs. Really easy. When you have a positive and a positive, you add them, it's positive, you multiply them, positive. Those are the easiest kind. This one isn't quite as bad. You have a negative and a negative. Well, when you add two negative numbers, you get a negative number. When you multiply two negative numbers, you get a positive number. This is where it gets confusing. When you have a positive and a negative, you're actually looking for the difference that goes down here. It's not adding them, it's actually looking for a difference, and you're looking for the sign of the larger number that has the absolute value that's larger, which is why I drew that around there. So we'll go through some of those examples, and you might want to change how you write this based on what makes the most sense to you. But the main thing is the top is always going to be negative because a positive times a negative is always negative. It's never positive. It's this that you have to be aware of, and you also have to make sure that you realize that you're finding the difference. When you're doing that, you're actually finding the difference on that one because you have a positive and a negative, so you find the difference. You take the sign from the larger absolute value number. Let's go ahead and try a few. Write this down, and then hit play when you're ready to try them. Here we just have two positive numbers, so again you need to remember product at the top, sum at the bottom. So 4 times 6, the product is going to be 24, and then the sum, 4 plus 6, 10. So that's all you're doing with that. And obviously they get more difficult, but a lot of them really are this easy. Two negatives, so same rules apply. Negative times a negative is a positive, so 2 times 3 would be 6. Negative plus a negative is still a negative. So some of you who have been having trouble with some of those rules, you've got to get good at those for this. Negative 2 plus negative 3 is negative 5. And then the last one is an example of one of these. 4 times a negative 6 is going to be a negative 24. The sign down here is going to depend on which number is higher when we're not looking at the actual sign. The absolute value of 4 or the absolute value of negative 6. That is your larger, so your answer is going to be negative, and you're just finding the difference. 4 minus 6 is negative 2. Copy these down and go through them and try them on your own. Once you're ready to correct them, hit play, and the answers will be up there. Here are the answers. Hit pause after I'm done talking, go through and check it, see how many you got right. If you miss one, make sure you take a close look at what you did wrong. And if you still have questions about why you might have missed it, ask me in class and we can go over it. The ones I really wanted you to pay attention to, here I just kind of did this so you would see an example of 4 versions using the same numbers and how they change. But the other ones that I threw in a lot of are the ones. It seems like a lot of students get really stumped and forget about the number 1 a lot of the time. Remember, right here, when you have a number at the top in your product that's smaller than your sum, and we're not talking about negatives, and they're only 1 away from each other, then it's probably going to be times 1. So that's a little hint there. Same thing, they're 1 away from each other, it's got a 1. 1 away from each other, it's got a 1. Even though it's a negative 1, it's something about 1. 1 away from each other, the number 1. So just be aware of that when you see that pattern. Some of the problems in your packet are going to look like this. And again, it's just practice at getting you used to thinking about these numbers and how they relate to each other. So when you're looking at this right here, if we stopped and looked at what 2 numbers are going to multiply to be 72 and add to be 17, and you just have to start thinking about numbers that would do one or the other. And once you find something that ends up being both, then you have your numbers. Something like this, you're looking at, this is my sum, so 5 plus something is going to give me a negative 3. Once you find this number, you can multiply them together to get the product. Okay, so that's kind of how these work. There's differences here. It's going to be something like a negative 3 times something gives me a negative 24. Once you have that and you have your 2 numbers, then you can find the other missing piece. Try these on your own. If you get stuck on any, just hit play and watch the answers. Just make sure you're getting the feel for how these work. Here are the answers. Go through, check yours, see what you got, see what you didn't get. Couple notes that I just want to tell you. First of all, sometimes I have students ask me, does it matter which one's which? If you have the answer -5, -4, as long as you have the correct sign with your number, these can be swapped. The numbers can be swapped. The sum and the product cannot be swapped. But those numbers right there, when you're putting them in, can be swapped. The other thing I wanted to point out that can help a lot of you, whenever you see a negative up here, as you're trying to figure out the numbers to make sure you're getting the right number here, what I tend to usually have students do is put a plus and a minus with no number. So when I went to go work this out, I just put in my positive and my negative. I didn't have numbers there. And then I thought about numbers that multiplied to be 15. I got 5 and 3. Once I had 5 and 3, I looked, okay, which one should the 5 go with if I need it to be a negative? And I put 5 there with the negative, and then I put my 3 in. That's just a little hint for some of you who might need help on that. Now we're going to move on to the rectangles. One of the main things that we're going to use the rectangles for is basically multiplying or factoring. You need to remember that factoring is like division, and so multiplying is like distribution. And so when we're distributing things or when we're factoring things, we're kind of doing the reverse, just like when you add and subtract or multiply and divide. And that's going to come up a lot in second semester. So this rectangle we're going to use right at the beginning of second semester in chapter 8. And what you're going to do is you draw a rectangle. Typically it has 4 boxes in it, but not always. You'll see times it has different size boxes to it. And each box is going to have a term in it, or just a number. You're going to look here to here, and you're going to pull out the greatest common factor of that term or that number. Here to here, greatest common factor of that term or number goes at the top. And then you're going to look at this row across, greatest common factor, and this row, and the greatest common factor. So you're going to end up with 4 numbers on the outside. Other way to look at it, if we reversed it and we had numbers on the outside, is what I'm going to show you next. This is the other type of rectangle you'll have. You'll have numbers given to you at the outside here, your greatest common factors, and what you're going to do is you're going to multiply these two that line up with each box to get your answer. So C goes across here, A comes down, A times C goes in this box. A times D goes in this box, B times C goes in this box, B times D goes in this box. And again, you could continue this forever. I could continue drawing new sets of boxes and just adding new numbers or letters or terms and multiplying them and adding on to it. And you'll see why all of this is helpful later. Copy these down, and once you're ready, hit play and we'll go through them. Again, you're just going to be looking greatest common factor here between the numbers 27 and 36, and you're looking for the greatest common factor. You can't just find a common factor, it has to be the greatest common factor. And when we look at that, it should be 9. Now you're looking for your greatest common factor right here between 6 and 8. And that should be 2, positive 2. Now you're looking for your greatest common factor across these rows between 6 and 27. And that's 3. And then you're looking between these two. And that's 4. Typically these problems aren't going to look like this because they're not going to have all numbers. They're going to have variables in them also and exponents. But I wanted you to practice with just the basic numbers, and then on the next page we'll do some others. Now, this is how you can check these. 3 times 2 is 6. So it's that idea of multiplying these two to get what's there. 3 times 9 should be 27. 2 times 4 should line up with 8. And 4 times 9 should line up with 36. So if you notice, these are just opposites of each other. Here you're multiplying 2 together. Here you're pulling that factor out that ends up matching it. When we're looking for our greatest common factor in this one, notice there are a couple negatives. We're going to have to worry about those in a minute. I'm not going to pull them up yet because I want you to see how it works, and then we'll write something about it on the next page. But our greatest common factor here would be 7. Greatest common factor here would be 3. Greatest common factor here, 4. Greatest common factor here, there isn't one, so it would be 1, because 1 is their greatest common factor. Now, if you're using the multiplication to check it, it's going to help you to see where you should put those negatives, and then I'll also tell you the rule. Positive 4 times positive 3 is 12. Positive 4, we already know that needs to be positive because it worked here. Positive 4 times 7 is a positive 28. I need it to be a negative 28, so I'm going to add my negative there. Same thing goes here. 3 times 4 worked, so I don't want to mess with the 3, but if I look at 3 times 1, I get negative 3 only if that's a negative. And I have to put it with the 1 because I don't want to mess with that 12. Then, if I notice here, a negative 7 times a negative 1 is a positive 7. So everything worked out. All right, let's try this one. So look at that for a second. And again, I'm just going to pull out the factor right now. I'm not going to worry about the signs. It's 3. The factor here, 2. The factor here, 6. Factor here, 5. So you're just pulling out those common factors. Now I need to deal with the negative though. 6 times 2 is 12, so I don't want to mess with 6. 6 times 3 is 18. I need it to be a negative, so I'm going to put the negative in front of that 3, and now I get negative 18. 2 times 5 is 10. 5 times a negative 3 is a negative 15. So that worked out. Try this one. Greatest common factor is 9. Greatest common factor is 7. 2. and 7. Now I have negatives to deal with. Again, a positive times a positive. 7 times 2 is 14. 9 times 2 is 18. 7 times 7 is a positive 49. I need it to be negative. I don't want to mess with that one because I already know that worked there. So I'm going to add it here. And then I check the last one. A negative 7 times a positive 9 is a negative 63. These ones, we're just going to practice the multiplication, the second part. So you just multiply. You get 42. Multiply 12. Multiply 35. Multiply 10. Same thing here, but just watch your signs. 5 times 2 lines up there, so we get 10. 2 times a negative 3, negative 6. 5 times a negative 3, negative 15. Negative 3 times a negative 3 is a positive 9. And if you were to go and pull out the greatest common factors, you'd have 2, you'd have 7, you'd have 6, you'd have 5. You'd have 5, negative 3, 2, negative 3, once you looked at the rule that we're going to talk about. Go ahead and add these hints to the right side or left side of your original notes if you can fit them on there. If not, start it on the other page. Once you're ready, hit play. The hints are typically going to follow this pattern. Notice our first rectangle is almost always positive. When it's not, you're going to have to make adjustments based on that. And we'll talk more about that later. But just make sure everything always multiplies out and is correct in the end. Whenever you see diagonal negatives like this, it's always going to follow the rule that the negative pulls out with each of these terms. And the reason for that is because you get positive times negative is negative, positive times negative is negative, and negative times negative is positive. So every single time you see that right there, that diagonal, you know you're going to pull out 2 negatives. This is going to end up being positive, and that's going to be positive. Every time you see this, where they're lined up, the negative is going to come out with wherever they're lined up. Now you have positive and a positive still here. Positive times negative is negative. And then you have to look here. Positive times a positive would still be positive here, and a positive times a negative would be a negative there. So it's always going to go with wherever it's lined up. Diagonal, you pull out 2 negatives with those. One line of it, one time where it's lined up. So in this one, same idea. Positive and positive here. Positive times a positive gives you a positive here. Positive times negative, and positive times negative. Hopefully that helps you out a little bit. Now we're going to try some more of these, but with variables. Copy this down, hit play when you're ready to go through it. So we're looking for greatest common factor in each row, and we just have variables and exponents to pay attention to. You're always looking at the numbers first, then at the variables. Right here, we don't have any common variables, but we do have a greatest common factor of a positive 2. So you can pull out a positive 2, and you might as well get in the habit of putting plus plus on some of these, because that's what we're going to do a lot of during second semester anyway. If you're looking here, they have a common factor of 1 for their numbers, but they have 1 x in common. Because there's 2 x's here, 1 x here, they have 1 x in common. If I look here, they have 1 x in common and the number 1, so that's an x. Here, no x's in common, but they have a greatest common factor of 3. Look at that again if you need to, otherwise try this one. So now we mixed it up a little bit. Greatest common factor we can figure out in this column right here. They have a greatest common factor of x. Now you can start to try to figure things out. Like I know x times something here is going to give me x squared. So it should be x times x. And now I can multiply x times a negative 4 to get to what goes in here. And I get negative 4x. Same thing, x times something here is going to give me 5x. So I get a positive 5. And then a positive 5 times a negative 4 is going to give me negative 20. So you're just working through those. If you want to hit pause and try them on your own, you can. Otherwise, you can keep going with me. Right here, I know I have a negative 9 times y that lines up, so I have a negative 9y. I also know I have a negative 9 times something that's going to give me a negative 45. Negative 9 times negative 5 gives me positive 45. Sorry, positive 45. Negative times a negative is a positive. 9 times 5 is 45. Now you have to start looking and trying to figure out if you can figure anything else out here. And you'll have to kind of think about what could go here. So let's just say, because we know a lot of these look like that right now, let's just say I put a y here and let's see if we can make it work. Y times y is y squared. And y times a negative 5 is a negative 5y. And I check them all. Y times y is y squared. Y times the negative 9 is a negative 9y. Negative 5 times negative 9 is 45. Y times negative 5 is negative 5y. And that works. Here, if I already know that p was pulled out, then I know that 2p would be left. 2p times p is 2p squared. I know how to multiply p times 5, and I get 5p. I know 5 times something here is going to give me 10, and it's 2. And now I can multiply 2p times 2, and I get 4p. And when I check it, the greatest common factor of 2p squared and 4p would be a 2 and 1p. Here, I don't see a greatest common factor with the variable or with the numbers, so a 1. Greatest common factor right here would be a 2 and a p. Greatest common factor here, 3 and a p. Greatest common factor here, 4. And then I check it. 2p times 3p is 6p squared. 3p times 1 is 3p. 2p times 4 is not 4p. 4 times 1 is 4. So I look again and I try to figure out, did I do something wrong? And I go through it. And I check everything. I found the greatest common factor there. I found the greatest common factor there. I found the greatest common factor there. I can't change anything. You're going to come across these. So sometimes you just circle it or do something and you say, doesn't work. And you'll find out why that doesn't work later. Okay, we'll talk about why that might not work later. And this is going to happen to you in the diamonds also. I was going to bring that up later, but I'll just talk about it now. In the diamonds, sometimes you will not be able to find something that works, and you just say it doesn't work, and you'll learn why in second semester. All right, let's try this one. 3p times 3p is a 9p squared. Don't forget p times p is p squared. That's a common mistake. 3p times 2 is a positive 6p. 3p times a negative 7, negative 21p. Negative 7 times 2, negative 14. And I check it. 2 works. 3p works. 3p works. and -7 works. If it didn't, I'd have to do the same thing there. There are 2 apps that I know of, and there may be more out there, but these are the 2 that I know of that I've checked that actually are good apps. And if you have an iPhone or an iPad or an iTouch or something like that, I know that these are on there. If you have any other type of phone or any other type of tablet, you're going to have to look for it, but you would just search for diamond problems in algebra, something along those lines. The 2 apps that I know of, one is called Diamond Factor, and the other one is called DiaMath or